All right, hello, welcome to the Off by One security stream on this Friday, May 10th, just after RSA is finished up for anyone who happened to be there this week. That's where I was at for most of the week. Did a couple presentations and such, but now back home in Berkeley. For once, it was a nice, easy drive to a conference. Don't have to actually fly there. I can just like go in and show up and do some things and get out of there. So again, welcome. We've got Ruben Boonin this week, which last time I think I saw you, Ruben, was at Hackfest last November. Sounds about right, correct?
Yeah, at Hackfest in Hollywood, yeah.
What was your presentation? What was your presentation on again at that event?
It was on extracting JSON web tokens, like from Windows endpoints that are, Entra ID joined or hybrid joined, and then
Right.
you can use those tokens to like talk to Azure services as the user at that point.
Right. Totally, I remember now. Cool. So yeah, like we're running Hackfest again this year on October 28th and 29th. We'll be putting a CFP up soon. Since you're nearby in San Diego, we're doing it up in Universal City this time, so that'll be nice and close. And it'll be right during like Halloween, during the Halloween horror nights that they do. So it's a good time to be there.
Excellent.
So, all right. Well, apologies for last week. Things come up a lot. I think last week I just showed up and we just did a lot of talking. We just did a lot of Q&A, talking about how to get started in the field and just lots of questions, which is always a fun time. I look forward to having those sessions. But this week we've got Ruben, so very excited on this one. He actually reached out there, which was awesome, to the community and said, what would you all want to see a presentation on? So I think we're going to get some great content on Frida, as well as, of course, security research problems and just a little bit of questions that people always have when having great guests on like Ruben, which is how do we get started in the field? Like one question I've been getting constantly. Let me ask you this question first, Ruben, actually, because I give my own answer, but
okay, go for it.
It's a good one for anyone, which is it's a two-part question. One is, if you were going to university right now and you were studying information technology and computer science, would you still go into security as a field? And then also, where do you think things are at with regard to binary exploitation? Do you think that there's still a career left in that area, or do you think it's better to go into a different field?
So yeah, like about the studying question, people may or may not know this, but I did not study computer science. I studied philosophy, if you can believe that. And so I think it kind of depends, like if it's worth to do that, to study secure or information technology and specialize in security or not. Like I know that, for example, in Belgium, which is where I'm from, once I decided, okay, like I want to work now, it was very hard to get a job because there was a lot of focus on the degree, which is why I moved to the UK, where there wasn't this focus. There was just like, do you have the technical aptitude to do the work? So I'm not exactly sure like what the situation is here in the US. I think it's probably more like in the UK, and I don't know if it's necessarily required to have a focus on security. I would say it's like probably a good idea to study, IT generally, if that if that makes sense, sort of.
Yeah, I think same thing. I didn't go to college. Actually, I went for criminal justice right out of school, right out of high school, and then switched over into information technology, network engineering. Didn't go to school. Went to school after the fact, got my master's and such, but it didn't really help me as part of my career in security. So I think, like you said, in the UK, same thing in the US. The more you know, it doesn't matter if you have a degree or not. Obviously, it helps, but it's not a requirement by any means.
But I do understand that there are some places like in Belgium. I don't know, maybe the situation is different now, but I remember going to like my first job interviews and people look at me like I'm some kind of alien, like a philosopher coming to do an IT job. And then, oh yeah, about exploitation. Like I think, exploit development is getting sort of more complex. Like over time, there are more like hurdles you need to go through. There are more mitigations. You need not like one bug, you need like 7 bugs or something like that. So I think the field is narrowing, like the scope of people who can do the work, like that field is narrowing generally. I don't want to say like, is it worth it to do that or not? I think it all depends on like how much time you want to invest, and what aptitudes you have, like things you like or don't like. You have to be willing to put in like a lot of work.
Yeah.
It's still possible, right? But I think the field is narrowing in general.
Yeah, absolutely. And one of the keynote that I did, I was part of a panel at RSA and was talking about the role of AI and LLMs and such, and how you can have these different agents now, and the agents focusing on like threat intel consumption, or agents focusing on doing the binary diffing. And like, for example, Greg Linares, Laughing Manus on Twitter, he, a long time ago, like before COVID, every patch Tuesday, he would go through all the patches and he'd just start throwing out there, like, this is a memory disclosure, well, this was this was that. And he was like really, really good at just blasting through those diffs and just saying what it looked like to him. And but that's a very manual process. So having agents that are focusing specifically on taking all the decades of data we have as to how Microsoft, for example, patches vulnerabilities, and then being able to scan the code base, or being able to take a look at the diffs and quickly identify what the problem most likely is, and then other agents working on potential weaponization or determination as to whether or not something's exploitable. But I don't think that anytime soon, anyway, there's going to be some agent that's going to be able to do all the heap massaging and grooming, all the things in real time that you need to do to make sure all the conditions are right.
Yeah, okay. Now I want to say, like, there's a lot of bogus hype, I would say, around AI.
Yeah.
But I think personally, I love this AI revolution that we're in. Like, as long as it's used like where it's appropriate. And so I've done some work as well around integrating like large language models with my decompiler, which is maybe something I'm talking about later this year. I don't know. We'll have to see. And I think that definitely, like, the models already can sort of speed up the work I do. They might not be accurate all the time, but they're very eager. So,
Yeah.
so like I can already see some benefits there, and I think like over time, as the technology matures, and it's been maturing at an incredible speed, like I think we will see those use cases, increase more and more, where we can offload that work to some model, maybe that's fine-tuned even on specific tasks.
Yeah, where I've been finding the most help with the use of LLM is giving AI decompiled code associated with something. Like, one of my go-tos is always look for memcopy calls, look for things like anything to do with compression or obfuscation or encryption, and the complex code that's determining what the dynamically calculated size argument for memcopy. It helping with that has been a godsend. It's been a huge
Mhm.
time saver.
Yeah, and of course, like sometimes it doesn't have, like, this is something I've worked on with the integration I've done in my tooling, is like sometimes, like, if you look at something in isolation, you might not know, like maybe it looks okay, but it turns out this variable comes from some other function, and it needs to somehow understand that you control it in that other place. So there's work to do there, but I'm excited about it as well, personally.
Yeah, absolutely. Yeah, I think I did a Twitter poll not too long ago and was asking what the job market looks like for people who have a lot of experience in IT, who may be out of a job or security, and then people who are straight out of university or just trying to get into the field as a beginner. And I was sadly surprised to see that the number of people saying how difficult it was as a new person to get a job right now is quite hard, which is the unfortunate part. So I think, we've been hearing for a long time from a lot of companies that there's this huge shortage of security professionals, and I don't know how true that is. I don't know how much of that is talent versus number of bodies, and I don't know how much of that is what specific roles might be a lot more in demand than other ones.
Yeah, I think probably I'm sure there is a shortage, like, generally. I don't know how big the shortage is, but I think where there is a pressing need and it's like hard to find those candidates is probably in like the more specialized roles, where it's not easy to find somebody who you can, you know, put in that position, and maybe less at like the entry level positions. So yeah, it's hard to say. It's hard to say really.
Yeah, I heard from a couple. I've been talking to a few folks over the last 6 months. One of the things that a lot of employers have been asking for, like red team leads and such, are asking for someone. How do they determine if someone has the skill set to where if they put a product in front of you and said, "Hey, there's undocumented protocols, there's this, there's that. We want you to do security research on it and be the type of person that can actually figure the stuff out on your own and just lead in that space." I think that's a hard thing to test for without a proven track record, but you know, I think there's a lot of opportunity there. So
Yeah, yeah.
cool. All right. Well, as usual, we've got a couple hundred folks on right now. I know that's going to ramp up pretty quickly here as we get into demonstration, which is most of what people come for. Less of hearing us talk. But um, if you have questions for Ruben or for us in general, please do post them up. I'm going to go ahead and share out the screen so Ruben can start taking us through some slides and some demonstrations that he wants to do. He is going to be giving away a seat to his training in this session. So stay tuned somewhere around the middle of this session for a trivia question we'll be asking based on the things we're going to be talking about. So I'll go ahead and share screen and I'll moderate questions as they come in.
All right. Great. Is that sharing out?
That's perfect. Yep.
Okay. Yeah. Yeah. I can't see anything now except my slides. Okay. Just so you understand. But yeah, I want to say like if there are questions like throughout, just feel free to ask them. It doesn't have to be about like the things we're talking about. Obviously, if it's a bit on topic, that's probably better. But feel free to ask any questions that you have. So just like a few details about me. You can see an AI Ruben here, which is scary. Okay. But I'm from Belgium, as I sort of mentioned already. I spent time in Africa and East Asia. Then I was working in security for over 10 years in the UK, mostly in London and in Basingstoke, if there are any UK fanatics here. Um, Doing all kinds of things like just consulting, offense, research, and defense. And now I'm in the US and I work at IBM on the adversary services team, where I'm CNE lead, whatever that means exactly. And then you can see some details about me, like things I love, Windows, of course. I'm a DIY programmer. I love to just, I don't know if the quality of my code is great, but I love to program. Post exploitation is, I would say, my greatest passion. Like you have access to some kind of endpoint, whatever that is, and then taking advantage of the facilities that that endpoint provides you to do things as the user, or take advantage of the access that they have to do things. That's sort of what I love the most. All kinds of strange R&D projects. Frida, of course, like we'll be talking about Frida today. But Frida is great as an instrumentation framework, vulnerability research generally, although mostly on Windows, and some like app testing, like web app testing as well. And recently I've been getting into Android userland, research and exploitation. We're talking a little bit about Android today as well. And then AI. It's not cringe if it's cool. Okay, let's not make it cringe. Let's try to put it in the correct context, right? And video games, of course. Cool. When I posted on Twitter or on X or whatever, people had like Of course, like Frida is a good topic to talk about, which we will do. But some people had questions about research. And so I made like a few slides about research that I'll go through just to give you some ideas about like how I think about research and what components I think are important for that. And then like if you have any questions like throughout, you can put them in the chat and I'll be happy to answer them, right? So like generally, like how should I do research? Like, I don't know. I don't, I don't have good answers for you. Like it depends, right? Like on the things you're interested in and what kind of aptitudes you have to pursue those interests. But leaving aside this question about like how should you do research, like I wanted to touch on like things that I think are important to be able to do the research and be successful at that, right? And so, you know, the first thing is like you have to enjoy the process. You know, research is a lot of work. You will invest like many hours. You know, they say this thing like you need to spend 10,000 hours to become an expert, right? Those are like rookie numbers, okay? Like if you spend, you know, a bunch of years doing research, you'll easily outstrip that, I assume. You'll encounter many issues, many rabbit holes and dead ends. So you need to, enjoyment is really important because you need to have a resilience against this perception that you invested time without a result, right? And then like it doesn't matter like what your focus is exactly, right? Web, Windows, Linux, Active Directory, you know, Android, iOS. Um, the important thing is that you enjoy doing the research itself. Because then when you have failed outcomes, there's still a positive outcome, right? Whereas if you're not invested in the things that you're targeting, you might feel that a failed outcome is just a failed outcome at that point. Good. You can see a tweet here by Yarden, which I really like, where she says, you know, she was doing some low-level research and exploitation, and she spent like in the last 36 hours, she spent 8 hours looking at like a raw physical memory dump, looking for patterns that might not exist. This is like, you know, peak madness when you're in like some complicated research, right? So that gives you an idea. Like you have to love doing that, otherwise it feels like a chore, basically. The other thing is important is the group is smarter than the individual, right? There is a lot of research out there that we use and build on. You can't and shouldn't start from like a zero knowledge when you do research. It's important that you find out like what information exists and you can like absorb that to like inform your perspective on your research area. And then, you know, I think researchers are generally pretty friendly. Maybe some types of research they might be friendly. They might not be able to share exactly as much as in other areas, but it's always good to talk to people who are sort of in the same field as you and get their input and feedback, you know, on the things that you're doing. Conferences and blog posts, of course, are still like the main body of work, I would say, for whatever research area that you're in. And then um, also I want to say sometimes you have this perception that it's not useful to learn things which are old and may not apply at all anymore. But I don't think that's true. I think even if you study like some old exploit techniques that are completely mitigated in modern operating systems, like that learning is not wasted because you're building a foundation for new knowledge, right? You're building on top of that. And then finally, um, I can't do it, right? There's this idea of having imposter syndrome, which is pretty, real, I would say. And it's like easy to compare yourself to somebody who has, many thousands of hours more experience, like doing the thing that you're interested in. So it's like it can be very confronting, but like you shouldn't look at it that way, right? You should reflect on your own progress and you know make some touch points to understand, like, where am I in my learning journey now compared to like 6 months ago or 2 years ago. And rather, when you see researchers that you admire a lot, like, use that as like a benchmark, like, I want to become as good as them, right? Use it as like a motivating factor, not to compare yourself negatively, right? It's easy to do that, but you shouldn't. All right. Okay. I love this. I love this GIF here with this kid like ingesting the knowledge, right? Um, yeah, this is the important part. You have to do the work. Um, like, practical labor and practice of your trade craft is like very important. Um, you can use that labor to create products that benefit you, personally, or that benefit you as in you're providing a product for the community, right? Like, write a blog post, do a talk, create a tool, help somebody else who's having like some struggles with like a technical research area. Um, and then, yeah, reading only doesn't impart lasting knowledge. This is my experience. People might have a different take on this, but like, oftentimes I find that, like, I read an article and I think, okay, this makes sense. Like, I understand how this works. I can do that. But when I actually go to implement whatever I read, I realize that there are many like intricate details I didn't absorb by just reading something. So I think it's important that you actually put your knowledge into practice regularly. Like, I wish we could do like whatever this kid is doing here. I love the audacity of trying to absorb trying to absorb the knowledge from this book. I wish we could do that, but it's unfortunately, it doesn't work that way. And then, yeah, so you can reproduce like research that's public, right, to hone your skills. Good, good. And then, like, align your research with your career goals. Um, Create value for yourself in your career. Like, how does like what you research fit into with like what you do? That overlap might not always be exact. I too have like research interests that don't overlap with the work I do. But it's important to try and align those things, right? Um, if you find that they're wildly divergent, maybe then you're actually interested in doing something else than what you're doing exactly. If that distinction makes sense. Good, good. And then there's like one more slide on research before I'll shut up about this. Research conclusions. Like, there's some researchers here that I respect, who have written some things about research or how to conduct research that I think are good resources to have a look at. Yarden, of course, who knows more about Windows than I'll ever learn. She has a good blog post on like doing security research. There's Alex Plaskett, who's a gangster, okay, and he's one of my former colleagues from the UK. Multiple Pwn to Own participant or winner, however we want to say that. And he's written a really good blog post on doing security research, like what's important and how to approach that. And Valentina, of course, who's been a guest as well on Off by One, who's like a ninja and a pleasure to work with. And I would recommend her the talk she did on exploiting or binary exploitation at SSTIC, or maybe you should call that stake. I'm not sure. A final piece of advice I want to give is trust in your own intuitions about what you think is important. My finding is that people usually don't understand anything. I mean, I worded a bit strongly here, right? But they don't understand what the value proposition is of something you're interested in, as well as you understand that. So I would say, like, trust in yourself about like what interests you and how to pursue that. And then other people, they will try to box you in to a perspective like they have of themselves, or of how they think your abilities are. And then, like, they might say something like, I don't understand why this person is researching that, so it must be wrong, right? And they'll tell you things like that, like, why would you waste your time on this? This is not useful. Or even more egregious, you will never be able to learn X, Y, or Z, right? So my advice is just to ignore those people. We see like a quote from the great Method Man here. You don't know me and you don't know my style, right? So yeah, just trust in your ability to understand like what is important like for you, and pursue that. I think that's where we end with the research part. So I don't know if people have questions about this before we move on.
Yeah, so far the question's been more about Frida, so I figured we let you get to that part before we get into some of those.
Okay, fair enough. Everybody gets the research part. Great.
Lots of comments agreeing with you and saying good stuff, though.
All right. Yeah, just like this, obviously, like I'm doing a giveaway during the stream. Like the stream is not really about Calypso heavy industries, but I just want to have like a slide here to explain this a little bit. Why don't I full screen this again? Technology, it's all about the technology. Yeah, so like training is not like a new thing for me. I think I've been doing training since 2016. I think that's accurate, like at conferences and privately. This is all live training. And like I think that's fine, but it's not always a great model. I think because conference trainings are generally like pretty expensive. So there's like a budgetary issue, right? And then it's not just doing the training at a conference, but you also have to pay for the conference, the travel and stuff. So there's this budget accessibility issue, I would say. And then sometimes those trainings are like about like really complex topics. And then you have this time boxed nature of the training, which is like, 3 days, 4 days, 5 days. And as the trainer, like my experience is that you have to compromise in how much information you can pass on to people in order to make sure that you can get through everything, right? So I think it's not always the right model, is my take. And so this is like why I started uh, Calypso Labs to like make my Frida training more accessible, to lower the cost compared to like taking it at Black Hat or something like that. And because it's self-paced, you have a better opportunity to practice and retain the knowledge, because like remember, implementing what you learn is the best form of like retention and being able to apply that. Yeah, so you know, you can see the URL here, and like the plan is to also have other courses that'll be added over time, but I don't have any real details to share about that yet. Cool. Okay, then we'll get into like the practical stuff, right? So there are two sets of practicals we'll do, like one on Windows and then one on Android. So how am I going to do this? Let me. So yeah, I mean, I guess okay. Good. Let's just have a look. So first, I just wanted to make like a small example. Let me see if I can zoom this. I want to make like a small example that we can sort of look at on Windows. So I wrote like a really like horrible little binary. It's not like doing anything crazy, right? There's two components essentially, like a server component and a client component. And I wrote this in .NET because that's like the most awesome thing. Okay, and then we can see like we start a name pipe server with a name like off by pipe, where we wait for a client connection. We can print some like message to say like, oh, you know, a client is connected. Then we initialize like some cryptographic material, we using AES with like a seed phrase here, like hello pipe, and then we encrypt a message, secret message in this case, which we write to the client, and we just loop that, right? So that if a client disconnects, you know, our server keeps listening. And then on the client side, like we do something similar, like the client says like it's starting, it tries to connect to this off by pipe, and then it says, okay, I connected, and then it attempts to read a message that it receives from the server, again, using this AES cryptographic material that we initialized. Notice like with the same seed here. The AES part is not like super interesting. We just generate key material here using like some pseudo random number generator that we seed with the password. Like we get UTF-32 bytes for whatever that string is. And we also apply a salt here. Oh, it's okay, it's here. Where we just reverse that essentially. It doesn't have to be like super secure, and then we iterate on that like 20 times. But this allows us to have like the same cryptographic material in the server and the client, and then you can see like encrypt and decrypt is just like taking a byte array and returning a byte array using that key material. So that sort of sets a stage for like the binary. I think we have it here, yeah. Yeah, so with an S, oh, let me see, can I make this bigger? Amazing, technology is amazing. So if we launch this like with an S parameter, that means it's in server mode. And then here, we connect to it like with C as client or as the client mode. And we can see like starting client connected to server, and then we fetch that byte array that the server provided, decrypted it, and we print it. And like here, we can see that the starting server, and it notifies us that a client connected, right? So we can do that like a bunch of times. We can see that clients connect here. So what we're going to be doing, let me pull up Obsidian. What we're going to be doing is we're going to call this binary, like with Frida, and then we're going to attempt to place hooks at a number of different places in like during the runtime of the binary, so that we can capture like in memory what the binary is doing. Now, I understand that this binary is written in like in .NET, and so we don't see any Windows APIs here, like specifically. However, like these high-level functions get translated down into like low-level API calls, right? So if we just think about this like in a general sense, like the client, when it connects to a name pipe, it's gonna call like create file to open that pipe. And then when it wants to read data from the pipe, it's going to use the file handle and call read file, right? And then when we do the AES crypto, of course, like we have these high-level abstractions using system.security.cryptography, but these, again, translate down to API calls in native libraries like crypt, decrypt, which is what we'll be hooking eventually. But let's start with create file W, right? So here, if I just paste this in, let me see if I can, let me see if I can zoom this also. Oh, what the hell is going on? Okay. Oh, not too, okay, that's too much, yeah. Okay, not too bad. Yeah, so here what we're doing, oh yeah, so here like we're going to be like injecting Frida into the client, right? And then when what we actually execute is some JavaScript with like a lot of language specific bindings to do some things like attach to native modules, and then we can hook those modules and print the arguments and stuff. And so like here we can see that what I'm doing is I'm saying module find export by name, and then I give it the API name like create file W, which is what we want to hook here. I don't know if it makes sense to hold those up here. Right, and then like on MSDN, you can see like what the arguments are, right? And then with this feature interceptor, we can then attach to that pointer that we resolve and print the arguments. Like here, you can see we are taking the first argument and at the address of that argument, we're reading a Unicode string. You can see because we are using create file W here, we have to deal with the Unicode strings and not ANSI strings, right? So here you can see the first argument is LP file name. So it's a pointer to a file name for the file that we want to open or access. And so we're just printing at that point. Now, how are we going to execute our client? Here I'm just like providing the path to the client, like where I compiled it. And as an argument, I'm adding C, so it executes in client mode. Maybe before I continue. Yeah, sorry guys, it's like Friday. My brain is a bit fried, yeah. This tool that I'm using is Fermion. It's like a tool I wrote. It's like a cross-platform Electron app that has Frida node integrated with it, and so we can use this to like execute our Frida scripts essentially. And we use this a lot in the course as well, right? I don't know if that can be shared out if people are like unaware of that. But let's execute our binary here in client mode. And we can see that like create file W is called like a bunch of times, like with some DLLs, right? We can see that, it accesses like the binary and like some config. We like access CLR, all of that stuff, right? And then here we can see that there's like this very typical name pipe path, which we presume is for the pipe that we're trying to open that the server created. And so if we look, let's see, what's this one? So if we then like update this a little bit, right? So we sort of identify that we are opening a name pipe here. And then if we want to filter to consider only calls that are related to the name pipe, we can just do some JavaScript, starts with, //dot/pipe. Of course, we escape backslashes here, right? And then we can say, okay, create file called on this name pipe. Now, the reason we're doing that is because, let's say return. Like create file, when it returns, will return a handle to the file that we opened, like if it succeeded. And what we really want to do is understand like what the value is of that handle. So here we can set like a local variable to set like capture is true, so that in on leave, which occurs like right before that hooked function returns, we can then print the return value in this case, which is like the handle to that pipe, hopefully. So let's just try that. There it is, right? So we can see like we filter those create file calls so that we're only looking at the name pipe one, and then when that call returned, it succeeded, and we print here like a hex value for that pipe handle at that point. Okay, good, good. Are there any questions about this in the chat while I?
It's a bunch of questions about, I don't know if it's directly about this part, but Khalid's asking what made you create the course about Frida on Windows, saying it's more useful in mobile because Windows has many hook libraries that are really good and easy to use with no need to write JavaScript.
Okay, we should address this outrageous comment. Okay, so like, yeah, there are like libraries to hook on Windows, like Microsoft Detours. You also have like libraries where you can hook in .NET and stuff. That's all true, but I strongly disagree that those libraries are better in any way than Frida. Like, it depends on what you want to do with your hooked code. So like, let's say that you're creating like some post-exploitation payload, like probably you do want to use one of those libraries like Detours or stuff or something like that. However, like Frida is first of all, really robust. Like many of those libraries, if you test them, like you will find a lot of edge cases where you create some memory corruptions because like they don't work properly, especially for the ones that are ported to .NET. So that's one thing. And the other thing is a lot of these native libraries are really bad to use when you're doing your initial work because you're stuck in a situation where you have to you're doing some research, like you don't really know what's going to work, right? And you prototype some code. And then at that point, you have to compile the code to like native code. And you have to like inject the code. You have to like get some output from it. And then you have to understand like, oh, okay, this is not working. So I have to go back and you have to make some changes. You have to compile, you have to inject, test. So you end up in a very slow, develop, compile, test life cycle, which is like going to take up a lot of time, essentially.
Yeah, it's a great answer. And I put another one of his questions up there where comments, which I think directly ties into what you were saying as well, in case you want to elaborate anything.
Oh, I can't see the comments right
Because
now.
the only thing I use it for is mobile. On the normal Windows Linux, I use normal hooking. They tend to be fast and they don't inject a whole library.
Yeah. I mean, like, I think there's a difference between, like, obviously it's great for mobile. We'll talk about Android, right? And I think there's a difference between, like, you have some operational requirements where you need, like, to inject, like, some small native code library that can do the hooking. But when you're doing development and research, I don't think it's, like, suitable to work with these native hooking libraries. It's better to do this. And then like JavaScript is a bit distasteful. Like I agree with that. But like prototyping and development is really rapid, right? So generally, like I'll do this like in Frida and JS, and then when I'm happy with the solution, I can then convert it to some native library like detours or something like that.
All right. Last quick question for now is this person on Discord wanted to run Frida on Notepad, but couldn't. I couldn't figure out why it wouldn't work because it doesn't have any migration enabled. Do you have any ideas?
Yeah, like you should be able to. You should be able to do that. We can do a quick test.
Notepad, Paint, and Calc, the classics. Yeah.
So here I'll launch. See, where is Notepad? It's in a few directories, I think.
System 32.
Right? System 32. It's
Wait, it's not there? They must have just moved it with Windows 11.
but I think it might be here, to be honest. I'm not.
Yeah, it might be.
Oh, there it is. There it is. Yeah.
Go.
So, like let me start it. So I think this issue the person is facing is like you have the old applications, right? Like you can see it's telling me actually there's this new version of Notepad. And so I think it's one of these, packaged Windows apps now, where you have like other constraints and stuff. But like in the traditional Notepad, you should be able to inject into it.
Yeah, cool.
All right. Okay, good. Yeah, so what's this? Okay, I pasted this, right? Yeah. So here, we hooked create file and we were able to like determine which create file operation was like responsible for opening that name pipe, and we got like the handle for it, right? And then the next step, if we think about the client, is like we have a handle to the pipe now and we want to read data from the pipe, right? And so like at a low level, that's going to happen with read file. So here you can see I added just another native in like export resolution for read file in kernel 32. And then I add another hook here for read file essentially, and then I just print, right? Let's see what happens. Let's see what happens when I do that. Right, we can see that read file is called like a bunch of times with different handles, right? Because when you try to read a file, you have to pass in a handle that you've already opened. So I'm printing those handles here. You can see them, 300. Sometimes they're the same, right? Like you might open a file and try to read it multiple times. And then here, you can see our previous hook where we captured this operation to open a handle to the pipe, and we get the handle value. And then we can see that read file is called twice using that handle value itself. And then, like, again, a number of unrelated read file operations occur after that. So what we want to do here is like update our code a little bit so that we can tell whenever read file is called, like, is it reading from the pipe at that point or not? So let me copy. Oh, God. Right. So what I did here is like the code is basically the same, but in create file, I don't just print the name pipe handle, but I also save it to this global variable here, so that later I check, like, if that's null, it means that we haven't captured the handle yet, right? So if it's not null, we check, like, what handle is read file trying to open, and does it match the handle for the name pipe? And then if it does, we just print the handle, and then we print some arguments of that function. So maybe I should pull this up as well. Right, you can see the arguments for read file here, right? The handle, the pointer to the buffer that is going to receive the data that's being read, the number of bytes to read, and the maximum number of bytes to read. Yeah. And then a pointer to a variable that tells us how many bytes it actually read after the operation completes. And then some stuff about overlap. We don't really care about that. So we print the address in memory wherever it's going to store that buffer, and how big the buffer is. And then again, we just set like a local variable to know, like, before the function exits, we want to see, like, did that return like successfully or not, because we can see that the return argument for read file is a Boolean, right? So if it manages to read, it will be true. If it doesn't, it will be false. So let's just go back here. Right? So we can see we get, again, the handle for the name pipe that we open. And then remember, we saw two instances of read file using that handle. So here we can see, like, in this case, like, the buffer would be stored at this address in memory. It has a size of 400 hex, which is like however much. And then this instance of read file returned 1. That means that it successfully read data out. And then we can see that a second call happens for a slightly smaller size for whatever reason. I don't really know why this gets duplicated. It's probably some artifact of like how these managed classes work in .NET. Maybe it's checking, like I've read data from the pipe, like is there more data to read or something like that. And then here we can see that read file returns 0, so it was not successful, I guess, because there is no remaining data that the server wants to send the client at that stage. Good, good. Let me just pull up the... Okay, great. I have no idea if any of this is making sense or not, but we'll just carry on.
Yeah, no, it's all good.
Okay, excellent, excellent.
Someone did
So,
ask if you ran into a case where Frida was crashing the ejected process when hooking NTDLL APIs.
no, generally not. Yeah, so this is sort of what I wanted to mention about like some of the native hooking frameworks. Like it's
Yeah.
been my experience that Frida is by far like the most stable when you know need to hook like some complex structures like an NTDLL and it's all like undocumented and stuff. But I think if you're crashing because of a hook in NTDLL, it's probably like there's an issue with the hooking code. Um, I'm happy to have a look later if you want to send me your code. Good,
Yeah.
good.
And a lot of times the
So
number of arguments is going to be a lot greater, obviously, of the native APIs on an NTDLL versus the ones you're supposed to be calling. So
yeah, and then like maybe you need to traverse like some data structure in memory and the pointer offsets might be off or something like that. So I expect usually that's like where the issue is in one of those places.
cool.
Great. Okay, so we saw that we had like these two read operations. This one was success. This one was a failure. And so we just update our read file hook just a little bit, where we save those arguments like the handle, the buffer, and the size into these like temporary variables that we can access inside onLeave, which again is like right before that function returns, right? And then here we just check if the read file operation was a success. So we check if it's like 0 or greater than 0, like 1 in this case. And if it is a success, then we print that information back out. And then remember that read file has a pointer to a buffer that receives the data that it's trying to read. And so we can again use some built-in Frida like methods, in this case, like hex dump, to actually dump that buffer, a buffer to the screen. So let's give that a try. Good, good. Okay, so we can see again, we got the handle. We know that read file is using that handle. It's going to save the data at this address, and in this case, the buffer size is 1024. Probably it's just like standard sized buffers. And then here is what what the read file operation actually returned from that handle. And we can see like some bytes that are unintelligible. They look random, right? But that's, remember, because they're AES encrypted by the server. So, as you see, we're slowly building out this instrumentation of this very simple client that we built for the server. Great, great. Excellent. Excellent even. Good. Then finally, it's cool that we like can get the data that's being read from by the client from the server. But we obviously don't know like what that data is, right? Because it's encrypted. And then in a final step, what we're going to do is hook the low-level like functions that are responsible to do this AES decryption and give us back the plain text data. So what I'm doing here is hooking cryptdecrypt in add API 32.dll, and then again, like what we've been doing this entire time, I attach to it, and then in a first instance, I'm just printing here like we call this cryptdecrypt function, and we got some AES decryption, or I thought like that's what I print anyway. And then again, in return, I want to print the return value because cryptdecrypt returns a Boolean, as you can probably guess. Returns a Boolean, right? So let's see what happens when we do that. Great. And we can see sort of similar situation to the read file where gets executed twice, once successfully, once not. So this may be an artifact of this double read that we try and decrypt twice, even if the one of the reads failed. Like, I'm not really sure. It's probably an artifact of .NET, the way that's implemented. Like at the native level. So good. So we're going to want to update our proof of concept a little bit, just like we did for read file, right? We save those arguments. Like one of the arguments, like the fifth argument, right? Because arg starts at 0, is a pointer to where the decrypted data will be stored, and arg6 is like the length, a pointer to the length of that data. Right? So when cryptdecrypt gets called, we save those in like some local variable storage, and then in onLeave, again, we check if the return value is greater than 0. That means that the decryption was successful. And then we print that information, right? The address where it's stored. We read U32 at the data length pointer to understand like how big the data is. And then again, we can use this built-in functionality hexdump. You can see the arguments here because like Fermion has built-in like linting and IntelliSense for the Frida language binding, so you can get like information here. So we read a byte array at the address of the data here, right? Read byte array at the pointer that points at the data, and we read it for a length of however long the data is, and we hexdump that. So good. And then here we can see we recover like whatever message the server sent to the client at that point. And then, yeah, I want to quickly say, like, I think you can see that it's easy, like when we're doing, like when we're in a research phase or when we're in a development phase, to prototype our hooking code and iterate very quickly. Like if you were using like Microsoft Detours, to come back to this previous question, how many times would we have had to recompile our payload, and then we'd need some kind of wrapper to launch the binary and inject into it at, before it completely initializes, and then capture that data. We'd have to add code to maybe log the data to like a file or something like that, and then we'd have to keep like recompiling. We'd still be here like 3 hours from now, probably. So it's
Totally.
like very fast to do that. Good. Okay, so that's the Windows part. Let me pull up the slides. Great. And so here we have this trivia question, like was mentioned before, like I'm giving away like a voucher for the course. And so there's this trivia question which you have to answer to, get the voucher, whoever does that first. Like we saw that we were able to decrypt the message, right? That the client received from the server. But you'll notice that like after this message, we have these 2 bytes here, 0202. And so the question is just like, why are those bytes there? If that makes sense.
I think it should be what type, don't you? Martin says padding, which is the answer. But what is the type of padding? We need to know this, Ruben.
Okay. Well, we can do that. Yeah.
Yeah, Kuba says PKCS7 padding, which is correct. PKCS5 would be for 8-byte block ciphers, 16-byte block ciphers, PKCS7, absolutely.
Who was the other guy, Martin?
So Martin said padding right away, and then Kuba said PKCS7 padding.
Okay, so like I feel badly about like the specificity of this. So like what I'll do is like I'll just give I'll give Martin and Kuba a voucher because I don't want to like to tilt people in the chat or anything like that. Like they didn't understand the assignment. Okay, so
that's super kind of you,
yeah,
Ruben. So yes, Martin and Kubas, you both get the class from Ruben. So write a nice review for him.
Yeah, this is a requirement, okay? Otherwise, but I want to quickly show, like, here the bytes are like 0202. That's because 2 bytes of padding are required here. If we do, I have this project open? I do, yeah. Oh, I'm in the wrong. So here the server sends secret message. But if we just remove a character here, and we can just rebuild this, right? Oh, we can't. Let me just shut down the server. Okay, so we rebuilt the binary. Now if we run this, we'll see 030303 because there are 3 bytes of padding. Just so you have some context there. Cool, very cool. So yeah, next is like the Android stuff. I don't know if people have any questions about this before we move on.
Let's see here. So yeah, I said real quickly for Martin and Kubas, DM me on Discord. If you're not on the Discord server, I just posted it up, and then I'll get that info over to Ruben so he can get you to free class. But yeah, before he switches over to Android, any questions remaining on the Windows side? Because he's gonna have to drop off for a second to jump over to another system here. Yeah, and speaking of which, since we did see that padding, I'm happy to do a session coming up soon if you want to see Oracle padding attacks and get into a couple examples of how you can actually decrypt data through doing Oracle padding attacks. I haven't tried Frida on Windows yet, but I think I'll try sometime. Yeah, I think that was a great introduction, Ruben, to help people out. So actually, I got one question for you. It was Hoshin Kodet wrote a tool a long time ago called MyNav, and it kind of based it off of Bin Navi, which I'm sure you're familiar with from from who was that? Dynamics back in the day. BinDiff and Bin Navi were from Dynamics. It was really cool because what you could do is rule out the startup code. So for example, if you wanted to identify a closed source application and only focus on the parsing code that actually parses through the metadata and opens a file, you can run the program twice. Both times it records all the runtime code leading up to the point when you go to open up the folder or the file. But then the second time it only shows the delta. So then you're only left with the functions that actually handle the parsing of the data and opening the file. Do you have any recommendations on that currently?
So you mean like doing some instrumentation, like on some part of the execution runtime, or?
Yeah, so like let's say I want to look at specifically at Windows Media Player. So I click on, I start it up, I'm instrumenting, fuzzing, whatever, I'm recording it. I say file, open, navigate the file system, click on the file, but I don't actually click the open button. And then I run it a second time. It records everything all the way up to the exact point of the first time, but then I actually click open, and then it only shows us the functions going forward that handle the opening of the file.
This is such a beautiful introduction to something we'll look at on Android. Yeah, so in Frida, you can use some functionality they have called Stalker, which is maybe not a great name, but like you hook a function, right? Like let's say, for example, here in read file, when you hit your hook, you can attach Stalker to the current thread, and then you can get coverage for whatever that function is doing, right? And then in onLeave, you can detach Stalker, and then you can like print the coverage, like all the addresses that get executed, like between attaching and detaching, and like commonly, like you'll find some entry point for like the code you wanna analyze or you wanna fuzz or something like that, and then you'll attach and detach at the correct place and extract that coverage. Is that a good answer? Or?
Yeah, it's awesome.
Okay, excellent. Yeah, we'll be doing that. Like we'll show a demo of that on the Android part.
Perfect. All right, so I guess you'll drop off and join back on in 10 seconds.
Okay, I'll be right back. I need to KVM switch for the just so chat understands. Okay, I'll be right back, guys.
All right, just me for a second. He'll be back on in a moment. Just jumping over to another system with this KVM switch so he can show us the Android session. So good stuff. A couple of you posted. Yeah, this will be up on YouTube coming right after this. As usual, will be posted there and live on going forward. Next Friday, just while we have a moment, I've got Yarden Shafir coming on, who Ruben just mentioned, of course, but just going to be an awesome session. I believe looking more at the forensic side of the house and maybe looking at things like what kind of footprint we leave behind when we go and do our attacks, some of that space. And we've also got a second stream on the same day next Friday with Larry Pesci, who's going to show us some really cool stuff in the realm of the wireless space. So one will be at 9 a.m. Pacific, and the other one will be at 11 a.m. Pacific. The second one will be Yarden. The first one will be Larry Pesci. So both of those will be awesome. And we've got more guests coming up after that. Ruben is back, so let me add him up here. Cool. I was just telling him that Yarden will be on next Friday, since you mentioned her earlier. I'm very excited about that one. So.
Yeah. Definitely come check out the stream. Like Yarden is, such a legend. You won't want to miss that for sure. I assume everything's okay. You can hear me. It's all good. All right, excellent. Why don't I see if I can present, share, screen.
There we go. It's up.
Okay. Okay, I don't know how we manage this. Okay, I maybe just so people understand, like I'm on ultra wide, but I've like killed half of the screen, so you don't have this huge thing to look at, but it's like hard to manage. I'm used to having more screen real estate essentially. Good. Good. Oh yeah, I should probably connect this phone here. So,
what do you think of the Android and iOS emulation platforms out there? You use those at all? Like Corellium?
Well, okay, yeah, okay. This is a good question, I think. Yeah, like obviously you can emulate devices like x86. Like it depends on like the architecture of your host machine. But if you're emulating like ARM on x86, it's going to be like incredibly unusable, I would say.
Okay.
Um, of course, if you have like an ARM device, like that's the reason. That's one of the reasons I'm on a Mac, even though people understand that I'm a Windows fanboy, is to be able to do some like ARM stuff natively on the OS.
Yep.
Yeah, of course you have like services like Corellium and stuff that you can use to get like properly emulated devices, and that's always an option, right?
Especially for iOS. Yeah.
Yeah, exactly. But yeah, here I'm connected to a physical phone, like a Pixel.
Cool.
Let's just see. Like I think, um,
Yeah, just font size increase would be all we need and perfect.
yeah, I'll do that in a second. Let's see. I think.
Hey, thanks for joining, Daniel. Appreciate it.
Oh, text, right? Oh God, what is it doing? I don't. Okay. Yeah, I mean, people will have to like forgive me, like because I'm a Windows shill. And
Command Shift Plus work under?
Command
Command
Shift.
Shift Plus.
No, does it?
Works on mine.
Oh, it
Oh,
does. It does. It
okay.
does. Okay,
Perfect.
I'm learning new things. This is amazing. Um, does it increase the others? No, it does not. Oh, yeah, but it doesn't matter. Here. Okay, good. We only really need this terminal here. So you can see like a sort of a view of the phone. There's like a tool, screen copy, that you can use. You can interact with the phone like without needing it in your hand and stuff. Um, which I don't know why I'm mentioning that. Just just for context, I guess. So we're gonna look at like using Frida a bit on mobile. And I want to give some context, sort of like what we mentioned earlier about, research as well, which is like finding things that interest you and that, maybe you didn't consider them before, but once you work on those platforms, you find that you enjoy that a lot, and then like you can do some knowledge transfer of skills that you already have. And I think doing testing on mobile is a really good example of that. So I took a course at ZeroCon of attacking instant messaging applications on Android, which was excellent. And I found that most of the skills I had already an interest in or I had already developed transferred to mobile sort of seamlessly. So as was mentioned before, like Frida is used a lot on mobile. And then user-land testing specifically on Android, you're going to be dealing with a lot of Java. Java is just like .NET, really, right? Like you could sort of squint your eyes and forget that it's Java if you wanted to. So yeah, so I've been getting into like Android user-land testing, and that's like we'll look at a little bit of that today. We can't go through like the whole thing because I wrote a blog post, and we'll go through sort of part of that, right? So here, yeah, okay. Maybe I should first, like, I don't know if JADX is readable at all. I have no idea where the JADX is so buggy as well, guys,
Hey, got
honestly.
it pretty quick.
Let's just hope it doesn't crash, to be honest. Okay. So yeah, we have this APK from Quark's lab, which they use in a blog post to talk about like benchmarking, like fuzzing native applications on phone or native libraries on phones. And it's sort of like a good test case for us to play around with, essentially. Here, we can see like it's taking some text and creating a byte array and passing it, to some native functions, like here, fuzzme array, which is a native function in a library that takes a byte array, as you can imagine. And then there's fuzzme wrapper, which takes like a complex object instead of a byte array. We can see, where is it? Wrapper. The wrapper isn't like very complicated, but it's like a complex object, right? Like you provide it, like the constructor takes like a buffer. It sleeps for whatever reason, probably to anger you. And then it creates a new byte array of the correct length and assigns that to like a property of the object, and then copies the byte array into that object, right? And it has some method. So if you have the object, you can do like get buffer, and it will return that property as a byte array, and then like it does this copy and returns it. Okay, like how are we introing this? Okay, yeah. So what we want to do is hook the application like on the phone, and we want to call this function here, fuzzme array. Now you'll notice that, as I mentioned, this is implemented in a native library, which is being loaded here by this class native helper as blog fuzz. And you can actually like see it here, right? Like within the resource section, you have lib, and you can see that there are a number of different versions of the lib. So coming back to your question, like earlier, like if you were emulating an Android phone, like in x86, you could still do this because there is a 32 and 64-bit version of this library that you could run on that emulator. But in our case, like we're running on a Pixel 7, and we are loading this version, ARM64 V8A, which is just like essentially 64-bit ARM, whereas this one, ARM EABI or whatever, this is like the 32-bit version, if I'm understanding that correctly. So blog fuzz, like when, oh god, look at this awful UI design. So when this native helper class calls system.load library blog fuzz, it's going to load this SO file, right? And so it's going to, oh my god, look, what did it do here? I don't understand this. And then these functions, fuzzme array and fuzzme wrapper, are implemented like as exports inside that native library. And so we want to hook those essentially. Now, like as our first, I should zoom this, should I? Fantastic, technology is fantastic. So yeah, we want to hook, we want to, in a first instance, just get the base address of lib blog fuzz in memory. This is like very similar to what we did on Windows. Like here, we're not getting an export, but we are doing like module find base address, and then we print that essentially. So let's run that. Okay, now if I just scroll, oh God. Okay, maybe. We'll just clear so that we don't have this horrible console history. So when we run that, we see that the lib blog fuzz base is 0, right? So it didn't manage to resolve that module in memory. And then here I just, I added some code to where I wrap like process enumerate modules again, which is just native Frida functionality. And then for each of those modules, I print some detailed information. So you can sort of see like what modules are loaded, like this address, this is the size of the module in hex, and this is like the system path where it's loaded from, right? Now there is obviously many modules that are loaded. So what we probably want to do is filter this a little bit. Can I just make a complaint about Mac? Like, why should I be using this Mac key to do like Control S, Control Copy? This is the behavior of a deranged operating system. Okay, good. So when we hit save here, it actually reloaded our code, and you can see lib blog fuzz is null. And then here, all I'm doing is like using some JS to filter any module names that contain like the keyword blog, because like that's what we're interested in, right? But you can see here that we don't have lib blog fuzz. Now, as I explained, like in the post, oh yeah, I shouldn't be copying this. I should just be executing it, right? As I explained in the post, like what I found is that this class, the native helper class, was not loaded by the application. I think that's because this app was developed to benchmark like fuzzing in a very specific way. It was probably not intended to be run like as a proper app. Because like if you read the Quark Lab post, like the way they do this instrumentation and coverage guided fuzzing with AFL is like very specific. It doesn't require like the app to actually be running on the phone. So I think that's what happened, right? But if we try and list all loaded classes, you can see like we get spammed here. There are many classes that get loaded for all kinds of stuff. And again, like here, we're using some built-in functionality. Java enumerate loaded classes makes sense. Like the name makes sense anyway. And then we just print those, right? Whenever we get one, essentially. But we can do like sort of the same thing we did before. We kind of filter based on QB blog fuzz. The reason we do that is if we look at the package name for this application, we can see that it's QB blog fuzz. In fact, you can see that what we're telling Frida here is like, okay, you know, like over USB, I want you to lowercase f start an application, and we give it the name of the application, QB blog fuzz, which is just a value I've taken here from the manifest. And so Similarly, like if we want to look at classes loaded by the application, we're going to want to filter those based on like some substring or starts with, and what I did here is just select like QB block fuzz. So let's try that. Oh, I need to save this. Not with Control S, but I need to save it. Oh, hang on. Yeah, so we can see that actually inside the app only 2 classes are loaded. Main activity is loaded. That makes sense, I guess. And then also this one, main activity, external synthetic lambda 0, whatever that is, seems to be empty. So only those 2 classes are loaded. Now, if we look at native helper, when this class is loaded is the point where it will load our native library. So clearly, like if our class isn't loaded here, our native library won't be loaded either. So that explains why we don't see this liblog fuzz SO in the list of loaded modules, essentially. So here, like in the third proof of concept, oh, I keep wanting to copy this. I don't know why. Here in the third proof of concept, or the third stage of this, I use a little trick. Like if you are familiar with JavaScript, you might know about like promises, where you have essentially a function that does something, and it has like basically a reporting mechanism where it can say, you know, this thing I was supposed to do is finished, or this thing I was supposed to do, I wasn't able to do that. And so here I create this function, load library async, with a promise, right? With resolve and reject, which means like it did that thing successfully or it didn't, with some like exception that you can print at that point. And then I load 2 classes from the app. Remember, these are the ones that we looked at. Native helper, which is the one that's actually going to be responsible for loading that module. And then I also load wrapper. In our case, like here, we don't need wrapper, but I'm just loading it as well in case we want access to that. And then later in the code, like I call that JavaScript function. And then using this then method, I can execute code based on that promise resolving or rejecting, right? You can see I catch, and here I can execute some other code. So
Quick question, Ruben. Someone's asking, Daniel's asking if you've tried using the objection framework before.
I have not. Yeah, I haven't used objection personally.
Okay.
It's because I'm, you know, Windows 5.
Use them all.
Transferring my skills to Android.
He's saying you can inject a gadget into an app. It's still confined by the app sandbox. So if you want a whole system, all apps to use Frida without building the app specifically for debugging, then yeah, you run Frida server, which would need to be root. So cool.
Mm-hmm. But maybe it's a good, like, are there any questions about like this so far, or does this kind of make sense?
Yeah, let me try going back up through here. Someone asking if it has verbose mode. Lots of comments.
Lots of comments.
Daniel said, is this the one where they target the JNI library directly? That was from a few minutes ago.
Yeah. Okay. I mean, the Quarks Lab post. Oh God, this window management here. It's terrifying. Quarks Lab post. Yeah, in the Quarks Lab post, they why does this not zoom? This Mac is infuriating. Yeah. Okay, in the Quarks Lab post, they target a few different. They target this app in like a few different ways. They target the native function. They target like here they like because they want to measure performance, right? Like if they're doing coverage guided fuzzing, they want to see like how is that performance affected by how that function is set up. And so here they target just the native function. Then they have like some benchmarks to target like this JNI interface, and then one with like the more complex object, right? Like we saw where you first have to create the object where you set the buffer as a property of it and then execute that. And so you can see like the performance differences based on that, but they don't actually run the app. It's a very interesting post. Like I recommend that you give it a read if this is, you know, something you're interested in.
Nice.
All right, great. Good. Excellent. So let's run this and let's have a look at the output. So now we see that we are able to resolve like the base address for this module because here in code we do like Java use, which means that we interact like with that class, right? And when we do that, the class gets loaded essentially. So once that happens, you know, our native helper class gets loaded by the app, and that triggers the native library to be loaded at that point. So here we can get the base address, and then you can see like I'm looping the exports again, which is using some built-in Frida functionality. So I say, okay, given this native library, I want you to give me all of the exports that it has, and I print like the export name, the export address. And so that's what we see here. Right. Now, can we, how do we set the, does anybody know where to set the font? Oh, font. What's it doing? Font? Does anybody know how to, how to set this?
See if somebody responds. I don't know.
And why, when I click up, it's like, modified by, okay, maybe we might have to put up with this. I don't know if there's a shortcut to, I don't know how legible that is, but
Yeah, it's a little small, but
it's a little small. Yeah, I can imagine that. Yeah, if anybody knows, like I'll adjust the font, I don't mind, but otherwise I'll try and talk through this, right?
Daniel
So
said you can hit Command Shift plus and it should increase the size dynamically. We tried that before. He also said you have to reopen Bingeal once you save it. But yeah, Command Shift plus should work.
Command Shift plus does not increase it for me. We can try here like font.
And it's pretty clear. It's just small, so people might have to zoom in. But yeah, don't
so
spend too much time.
this is modified by user. So maybe if I, does that work? I guess not. Let's see if it's bigger if I reopen it.
These are the demo gods. That's why it's always a challenge to do live demos, but I'd rather have live demos with challenges from the demo gods than no demos.
What is Binja doing? Why? Oh, okay. Oh, it did. Incredible. Oh, it didn't change it here. What the hell is this? It's just an insane view right now. Oh my God. So I think this was so this must be for the interface. Okay, maybe I should have used my brains. This must be it, right? So wait, so this must have been 13. Let's put that back, and we'll put this at like 19. Okay,
It should
let's
just
try
work.
that.
Why?
Let's see. Okay, this looks reasonable. And then if I open it, that's better, right?
Yep, way better.
Awesome. So yeah, if we look at this, we can see the exported functions from the native library. And then I've just opened the SO file in Binary Ninja, and we can, oh, is that helpful? I don't know if that's helpful. We can see those same, exported functions, like these are the interfaces that the app talks to, right? Blog fuzz native helper. This is the one that takes a wrapper. We can kind of see that we get this object and we call a method on it by ID. The method is like get buffer here. And then we pass that to this fuzzme function. In the other instance, we more directly like we get the array, of course, and then we more directly call fuzzme. So you can start to understand as well like why Quarks Lab did this different setup so that they could benchmark fuzzing performance in like different configurations. And then if we look at fuzz, this is a lot to deal with, this font size. If we look, yeah, okay, like here, like the decompiler is kind of doing not a great job, because you can see it's just made this huge if condition that goes on for a very long time. Right? Not great, not great. But if we look at the disassemble code, it'll sort of make more sense. Here, like the function does a length check on the input. We can just display this. So like if the length of the input is less than 16, the function will sort of exit, right? And then if it is not, it will go through the buffer that was provided, and it checks characters individually. For example, the first one is Q. This one is U. This one is A. Let's do one more. Don't worry, I'm not going to do this whole thing. And so we can see, like, it checks is this Q, U, A, R. Like, if it matches, we execute more blocks, of course. If it does not, like, we go to this like return condition where we return to wherever we came from at that point. And so the way that this fuzzing benchmark works is if you provide the correct string, you what did I do here? If you provide the correct string, you traverse all of these blocks, and then you basically execute a null pointer. So you trigger like a synthetic crash, and you want to check like how long does it take your fuzzer to find this crashing input, basically. So Good. Let me see if I remember what we were talking about. Yeah, so we managed to force the application to load the library, and then we were able to enumerate those exports, right? So like just on Windows, we can now like place hooks on those exports, like with interceptor attach, just like we did with read file, etc. Let me just see. I think I demonstrate just something first before we do that. Okay, let me try and pull up the phone here. Now, like something which is really interesting, and maybe we should bribe the Frida developers. I've tried actually. It hasn't worked so far. Like in Frida, you can not only instrument native code, but you can also instrument Java code. We've already sort of used some Java code here, like Java use, and you can see that we're using here Java perform. And I'm not going like into too many details here, but uh, we can also, of course, like call native Java functions. Now, this is just something I looked up with some Googling to see like how could I use Java to show a message in the app. And I saw that there's this class Android widget toast where you can create like a toast message. Essentially, you can see we call a method on toast make text, where we pass in like the toast text, and we need to pass it in a context, which we get like get application context again from like some native Java class like Android app activity thread. We just get our current application context. Like the details are not very important here. What I want to just show you is that we can execute like whatever kind of Java code we want, really. Here, in this case, just a toast. But you could execute whatever you want by sort of importing methods. And then very similar again to like how you would do this even in .NET, like calling, methods on those things that you imported at that stage. And so here, if we save this, you'll see that on the phone, like a toast message appears. Let's try that. You see? Hello, Frida. And that's just like our message here. Like, it's not supposed to be Jumanji, but whatever. Yeah, right? So you can see like with Frida, we can introduce like entirely new Java code to do like whatever we want into the application. Okay, I guess I just wanted to demo that because we don't really talk a lot about the Java stuff in this. Exit. Okay, so 5. Good. Now we were able to load the native library, libblogfuzz. That means that we can do exactly like what we did on Windows, right? We get an export from libblogfuzz, in this case, native helper fuzzme array, which is triggering that fuzzme function. And then we can do interceptor attach, just like we did on Windows, where we here print like on enter, like we execute that function, and in on leave, like we leave the function. And then of course, like we need to actually be able to get the app to trigger that native library. And what we're doing here is just we're implementing a call to fuzzme array. So I just take like a string, and then I use like a native Java array of the type byte. And then I map the char codes, right, for whatever string I provided here. And then I get a reference to this class, and then I can call the function, right? I have to instantiate like an instance of the class, and then I can call it like with the buffer or whatever. So let's try that. And you can see I'm looping here. So we call that like a few times from Java in the application. And then our native hooking code, which executes like in liblogfuzz, gets triggered whenever our buffer is passed to that function. We can see we enter and exit the function, enter and exit, enter and exit, just like we did on Windows. Great. And then finally, because I've been ranting a lot, I think, finally, we want to do something that you mentioned earlier, which is like understand like what code paths get executed whenever our function is called. And we can do that, like I mentioned, with stalker follow. So here, when we attach to our function, we place our hook. In onEnter, we do stalker.follow. We attach to a thread, and here we can just say like attach to the current thread, and then we can capture different types of events, which is not really important here. And then essentially we can get whatever like addresses get executed and add them to a coverage set, which is just, you can see like an empty array here. And so we can push data into this coverage set. Now what I'm doing is I'm taking the address that gets executed and I'm subtracting the base so that I have the absolute offsets inside that module. Yeah, that's what we do. Like, so every instruction that gets executed, we push coverage to our coverage set. And then in onLeave, we unfollow the thread, we do garbage collection, and then flush is like we flush any data that may still be in the buffer that hasn't been written yet. We force it to get written out. Good. And then we print the coverage length, I think. Let's see what happens when we do that. Right. Now here we can see like we call the native function and we get coverage again, like we're calling this in a loop, right? That's why we see it here multiple times. So we see that we get coverage counts. Like apparently there were 97 instructions executed in these cases. Now, if we look at this string, the string has 3 correct characters, Q, U, and A. So if we add one here, like R, and we save, we can see that the coverage goes up because we execute more blocks here inside of the fuzzme function. So at that point, like we can tell like which inputs generate more coverage and which don't. But what else we can do? What else we can do is actually get better information about what that coverage is exactly. So am I printing? Yeah, I think I'm just printing all of this. So, oh, yeah. So here I'm doing 2 things, like I'm printing those absolute offsets that get executed inside the binary. And then I'm also like transforming those here below. And so we can kind of see like where this execution happens, right? Like in limblog fuzz, like I'm in this, JNI interface executing, and we can see like which offsets get executed, and then like apparently we execute some function to understand like what was the length of that byte array that was passed in. That makes sense. Like we want to know like how big it is, and then we can see that once we return from that, we return back into fuzzme array at like some offset that's greater than before, right? That makes sense. We do something else here. I guess we get the elements of the byte array. That probably makes sense as well. And then eventually that gets passed into fuzzme, as we know, and then we execute, some amount of addresses in this tree here, depending on how many characters were correct in the buffer that we passed in initially. Now, that's pretty cool. Like we can look at this, but the reason I'm also just printing the raw addresses is because we can save those like in a file. You can see I've done it here already when I prep this demo. These are the same. You can see these are the same executions as I recorded here. And now with this file in Binary Ninja, we can do like, we can use Lighthouse. Am I in the right place here? I'm not, am I? Oh, off by one, okay. Okay, we get some complaints. But we can load that coverage file, and then now we can actually see, like here, for example, in the fuzzme function, we know that this coverage file was for a buffer that had 3 correct characters, Q, U, and A. And then when it did the comparison for R, it failed, obviously, because our buffer wasn't correct. And then it jumped to here where we returned out of that function. And so you can, paint coverage in your binaries as well using Frida. And I think that kind of comes back to your previous question that you had. And I think that's it. That's all I really prepared, I think. Let me.
Yeah, no, that's a lot. That's great.
All right. Oh, I'm creating this weird effect here. Why don't I?
Yeah, I'm gonna put it back to normal. Here we go.
Yeah, perfect.
The
Okay.
inception loop or whatever you want to call it.
Yeah.
Yeah, somebody asked earlier if you think there's a lot of similarities between reversing on Linux and reversing on Android.
I mean, okay, I'll give you my honest take. My honest take is like I don't really know. I'm just like when I was okay, like I love Frida, of course, and then I sort of understood that Frida's used extensively on mobile, like on iOS and on Android, like for vulnerability research, and also like regular application testing, like for customers and stuff. And as we know, like every 2 weeks, our phones are pushing updates where they say like, "Ooh, we're getting some new stickers," but really, like, there's some in the wild exploits for like, WebKit, and then like it's with some kernel privilege escalation. And so like I wanted to do some training around that, so I had a better understanding. And yeah, I took this training like attacking instant messaging applications and on Android. and I found that I really enjoyed that because there was a lot of skill transfer, both for Frida and Java. It turns out that I like Java. Maybe there's something that's wrong with me. But yeah, so I haven't, like, my focus has been mostly like on user land app testing. And I've been doing some research on a messaging app called Line. I don't know if anybody knows about that. It's like big in some parts of East Asia, especially like Japan, Taiwan. And then my plan is to write like a series of posts about that, where we look for like some cool stuff in Line, maybe do some post exploitation like that you might see, threat actors do, like, for example, injecting into the app to extract like messages from SQLite database or looking for some bugs in Line and stuff. But I don't have a lot of foundational knowledge about attacking, how to say, outside of the app space, like attacking the OS itself.
Right.
So yeah.
Yeah, for sure. Well, again, I mean, I appreciate you being on here for so long. That's 2 hours. So that's basically gave folks a free class. So really appreciate
No,
that. And congratulations to the 2 winners of Ruben's class. I'm going to post it up one more time. Check out Ruben's class here. You got the link up on the screen for Windows Instrumentation with Frida online. Do you have classes coming up in person? Or are you teaching at Black Hat?
Yeah, I am teaching at Black Hat. Let me get you the link. If I can find it. I'll post that maybe here. Can you
stick
see
it in the
that?
comment, and we can put it up on the screen. Oh, private chat. Okay, cool. I got it. I'll grab it.
Perfect. Cool. Yeah. So I'm teaching the class live. Yeah, at Black Hat. It's like the 4th year. I've been doing it like 3 years already. And essentially, like, the material is very similar. The only thing I would say about the live class is, like, there is a lot of work to do in the class. You understand? Like, I believe in doing the work, and there's a lot of work. So I think it sometimes is like hard, like, on people, which is part of the reason why I think like sometimes self-paced is better, because you have more time to like digest and become more acquainted with all the knowledge.
There's definitely pros and cons to both, for sure. Both modalities. We'll squeeze that last question in there from Janik. Is it possible to fuzz Android native files without Frida?
I don't know. I'm the wrong person to ask about this. But like, what I would say is, like, yeah, read the Quarks Lab post, because like they have some really good documentation on like doing this dynamic instrumentation, where they have like an AFL with Frida mode, and their performance is like outstanding. It's like 10,000 executions per second, which is way more than I get. So yeah, this is part of like the work I want to do, is set up like a proper fuzzing environment, both for like native code, but also like in Java fuzzing.
Yeah, for sure. Cool. All right. Well, I won't tie you up any longer. Really, really appreciate you coming on. And again, I'll post up one more time. Where to go? Ruben's class here. And we will see you next Friday with Larry Pesci on wireless hacking, and also Yarden Shafir taking a look at some, I think, offensive forensics and some other good stuff we'll look at. But other than that, have a great weekend. And thanks again, Ruben. And we will see you next time.
Yeah, it's my pleasure.
Bye.